In this video we are going to solve this LP from the practice quiz graphically. So we start the process by plotting all the constraints. Alright, how do we plot the constraints? We essentially replace all the inequalities with equalities, then draw the corresponding lines and also show the half planes that are feasible with respect to each constraint. So let's start by looking at the first constraint. We have x1 is less than or equal to 6. It's very easy to draw the line that corresponds to x1 equal to 6. So let's draw this line on the plot. We see that this is the line E from the plot, and let's show the part of the plane that's feasible with respect to this constraint. We'll use this arrow here, the points to the left of this line satisfy the constraint 1. Next, the second constraint, 2x1 plus x2 is greater than or equal to 12. So first, we draw the line for which 2x1 plus x2 is equal to 12. There are several ways of how you can draw the line based on the equation. One of the easiest ones is just to take 2 points that satisfy the equation and draw the line passing through these 2 points. The 2 points could be obtained by setting one of the variables to 0 and computing the other one. So for example, if we set x2 to 0, then 2x1 is equal to 12 and x1 is equal to 6. So 6, 0 is the first point. 6, 0 is this point right here. And then to get the second point, we can set x1 to 0, then x2 is going to be equal to 12. So we have 0, 12 is the second point, and our line will pass through these 2 points. So let's plot the line here. This is the line F, as we can see. So let's indicate the fact that the first line was E, the second line was F. 2x1 plus x2 is greater than or equal to 12. And if, let's say, I plug in 0, 0 for x1 and x2, I can see that the origin doesn't satisfy this inequality. Therefore, the opposite part of the plane will be feasible with respect to this constraint. So let me indicate it with the arrow here. The third constraint, x1 plus 2x2 is less than or equal to 12. Again, we plot the 2 points first and then draw 2 lines through these 2 points. By setting x2 to 0, we obtain x1 is equal to 12. So 12, 0 is the first point. And then by setting x1 to 0, we obtain 2x2 is equal to 12. So x2 is going to be equal to 6. 0, 6 is going to be our second point. Drawing the line passing through these 2 points, we get this line right here. This is the line I. So the third one is I. x1 plus 2x2 is less than or equal to 12. So the origin is on the right side of the line. So the arrow points in this direction for feasibility. So then finally the last constraint is x2 is less than or equal to 4. x2 equal to 4 corresponds to the line L. And less than or equal to 4 would be the points below this line. Alright, so this was line L. So we plotted all the 4 constraints. And looking at the arrows where they point, we can see that the intersection of the half planes corresponding to the feasible parts with respect to each constraint is given by this area right here. So this is our feasible region, okay? And we can see that out of these 4 points shown on the plot, we had P, Q, R, and S. Only the point Q was within the feasible region, so the rest were outside. Now, how do we find the optimal solution? We need to plot an isoprofit line. So our objective is 4x1 plus 5x2. we need to set 4x1 plus 5x2 to some value to obtain a line, right? So let's say, let's use 4x1 plus 5x2 equals to 20, for example. Then 2 points that will define this line could be 5, 0 is 1 point, and then 0, 4 the other point. So let's draw a line passing through these points. You have 5, 0 is 1, and then 0, 4 is the other. Let me draw the line passing through these 2 points. So now this line shows the slope for the isoprofit line. When we increase the right hand side here, our line will be moving up, right? And we see that the optimal solution will be given at this corner right here of the feasible region. So this is our optimal solution. So our optimal solution is going to be x1 star is equal to 6, x2 star is equal to 3, and then z star, the optimal objective value, is obtained by plugging in 6 and 3 for x1 and x2 in the objective. So we have 24 plus 15 is 39. All right, so we solved the problem. So now let's answer the questions from the quiz. First, we have to answer which lines from the plot we are using here. So let's go back to our solution. So we had E, F, I, and L. The next statement is an isoprofit line corresponding to the profit of, and we need to fill in the profit, is given by the line on the plot. So this means that one of the lines on the plot is actually an isoprofit line. Alright, so going back to the plot, we can see that there is only one line on the plot that has exactly the same slope as our isoprofit line that we drew here, and this is the line H. So looking at the intercepts, they are 8 and 10, so the slope is exactly the same as for our objective. And to find the profit level corresponding to this line, all we need to do is just plug in one of the points that belongs to this line in the objective equation. So you have, for example, 10, 0 is one of the points that belongs to this line. When I plug in 10, 0 in the objective, I get 40. Or I could have taken, let's say, 0, 8. I plug in 0, 8, I get 40 as well. So the profit level for this isoprofit line H is going to be 40. So therefore, we report H and 40 in the blanks here. So you have 40 and line H. The next few questions ask which of these 4 points are feasible, and we saw that only Q was feasible, P was not feasible, Q was feasible, R is not feasible, then S is not feasible, and the optimal solution was given by this point right here, so it was 6, 3. And the Z star was 39. So we submit, and we see that the answers were correct.